Well, hey everyone, welcome back to the shop. Today's video will be part 3 of this large wobbler engine build, and today we'll be concentrating on the piston. Now the piston and connecting rod and big end is all one assembly. However, in the original plan that I stumbled across when I found this job, called for bright mild steel big end and connecting rod as one piece with a threaded end on it which would screw into the piston head. Now we decided to change that, myself and my other assistant at the high school where I work, Mr. Bannister, and we've decided just to go with full brass piece here. Okay, now the total length calls for 85.73. I'm going to shoot for 86. I'm not worried about 1/4 millimetre. Overall, it's not going to affect anything. So the strategy I'm going to use today is face both of these ends, probably centre drill either end, hold it between centres, so I'll probably just machine up a quick centre in the chuck, use that as a driving centre, maybe put a bit of paper on there for a bit of friction or put a bit of super glue on there to hold it, come up the other side with a live centre, machine it down to about, I think it's 19.05 is the correct size, okay, which is 3/4 of an inch. However, I'll match it to my cylinder here. Now, if you recall in the other video I shot part 2, the size I got for the internal bore here was 19.07. So if I shoot for 19.05, I think that'll be right. I don't want it too tight a fit. This doesn't need to be a lap piston. It's not an internal combustion engine, so we should be right. Now, I won't have enough material left over to make this little end plug. Now, this little end cap here is what goes on the other side to hold the flywheel on, okay? And we usually have enough on this material, on this blank, that the students get this out of it as well. So this is one we made earlier in class during a demonstration, so I probably won't be covering that in this build, but as you can see, it's not hard, and I can talk about that later. All right, so let's get the rotary phase online. So I turn my 3-phase power on in the shop, get over to the lathe, and let's start doing these operations. One thing I forgot to say is to do the flats on the bottom of this big end here, I'll be holding this in my little collet chuck, ER32 collet block, sorry. Now this is a hexagon one. I've been waiting for my square one to come. I thought I would have had it by now, but you know what it's the postal service is like during this whole COVID crisis, so it's really painful. Now you might be able to just see that on camera. I've set up my little finger dial here with my Nomag magnetic base on the back of the middle, and I'm just going to sweep along the top there just to make sure that I'm in the correct plane here. It's not going uphill or downhill. Not that that will matter that much, okay? Really what matters is, am I in this plane here? Because that's the side I'm going to be milling on. Had I had my square block, I could have milled on the top, flipped it 180 and milled on the other top. I don't, I've only got a hexagon collet block here, so that means I'll have to cut on the side using the side of the mill tool, which is fine, but I'll have to cut this side, step up, over and down, and take a cut on this side to get the 12.7 thickness of that big end bearing. See that I've got the part set up here in the collet block, in the ER32 collet block. Remember, I've kept it oversized at the moment. It's currently at 19.5 millimeters. Now I need to drop in with my end mill on the back side and the front side to get down to the size that I need. Now the finished size here is 12.7. So I've done a little sketch for you to show you. So obviously the circle is the 19.5 diameter. We've got a centre mark on that circle. And you can see my right and left side, all right? Now the waste material I need to remove is approximately 3.4 millimeters on either side. So let's get into it. Let's remove this material. So I've taken the piston out of the lathe and I've put it back in my ER32 collet block here. Now, trap for young players, I probably should have drilled the hole and mucked around with it when I already had it set up. However, I'm in a hexagon holder here. I really needed my square block and I'm still waiting for that to turn up in the mail. Anyway, I've touched off on the outside. I've come in, found the centre, touched off on the end and come in and found that. Now the measurements are here for the hole. It's an 8mm hole, it's a through hole. It's got to be 9.53 up from the end, but in that centre line on that centre mark there. All right. So I've put a centre drill back in, not a spot drill, sorry, and we'll just drill that hole now. Just sneak up on it. Now, I really need a little mill jack here, under here, a little machine jack, and I don't have one. But as luck would have it, I'm using my mill stop here and I can lock these arms. And what I did off camera, I machined a chamfer on one end here to a point, 30-degree point, and I've picked up that spot drill hole in the end here. And that's just offering a little bit of security there while I'm drilling. If I just take it easy, I should be right. Now, something I didn't mention was I had to clock this in. I had to put it back in here and clock across this face to make sure that I wasn't twisted. All right, so I'll change over the drill and we'll drill that now to 8mm. Well, ladies and gentlemen, that concludes our video today of making the piston for the large wobbler engine. Hopefully you got something out of that. It wasn't all that complicated, to be honest with you. It does work. Now, one thing I have noticed with my old Colchester, when using the tailstock, I'm going to have to adjust it. So from this distance to this distance here, I'm getting a difference of about 0.2 of a millimetre, which is not good. Now for my piston here, so when I was miking it, I found that this was spot on at 19.05 and this was undersized by about 0.1. However, so it's a little bit tapered, but look, I can still get away with that. If I do the old compression sort of test here, guys, if I'll show you something. So if I drop that, hang on a sec, I've got to cover up both holes, sorry. And okay, we can see that it's going to work. Now, before I go, I'd just like to say thank you to Man Cave Metals. Man Cave Metals sent me this awesome sticker in the mail, and no doubt it will look good on my sticker board. And at the moment, my sticker board is my CNC machine, but I need to change that, okay? Another big thank you to Cutting Edge Engineering up in Queensland, my old stomping ground. Cutting Edge up there sent me some lovely stickers and also a nice stubby holder as well. Okay, so thank you very much for that, Cutting Edge Technologies and Man Cave Metals. And on that note, guys, we'll sign off, and next week we'll be looking at making the flywheel plate. So I'll be marking out drilling and then machining, making a mandrel, machining it round and fitting it inside the copper ring. So watch this space, and we'll see you back here next week on the Aaron Engineering channel, aka Pop's Man Cave, as my granddaughters call it. Good on you guys. Have a lovely weekend and stay safe, stay well.